Welcome back to another episode of Heavy Wireless, a Packet Pushers Podcast Network podcast. Glad to have you with us. And today I'm talking with Tom Carpenter of CWMP fame and wanted to talk about the premise of how do we move from Wi-Fi only to wireless? A lot of the people who went through the CWMP program started with CWNA or even CWT or something underneath. But you started years ago to augment Wi-Fi with other wireless protocols. So you want to tell us a little about your journey as CWMP, but you personally of why you moved that direction to help the rest of our audience also move that direction too.
Sure. And, it's interesting because when CWMP first started, long before I was around, their goal was to help people understand all the complexity of these standards and the technologies that make Wi-Fi work. But interestingly, when they named the organization, they named it the Certified Wireless Network Professionals, or CWMP, and not Wi-Fi. And it opened the door for that opportunity eventually to not just be focused on Wi-Fi. And early on, you probably remember, back in the 2000s, we call them now, they did launch a certification called wirelessHART, where they attempted to look at other things like Zigbee and 2.16 actually, and a few other protocols. And
we just have to back up a second. You mean wireless plus?
Yeah. And what happened is the industry wasn't quite ready for it yet. But remember, this was like 2006 timeframe, and IoT wasn't even a word we were using. No one was really thinking about the Internet of Things. In fact, the first IoT conference didn't happen worldwide for like another year or two after that. And so the industry just wasn't quite ready for it then. And we continued on with Wi-Fi. And wirelessHART actually became CWTS instead and focused back on just entry-level Wi-Fi again. And then back around 2017, as an organization, we started looking at where is IoT, what wireless protocols are being used in IoT, and is it time to start looking at this more seriously again? By that point, Zigbee had really exploded. A lot of Zigbee being used in industrial environments and manufacturing environments and things like that. And we realized there is a much bigger market out there now, and there's a need for this education. So then we spent the next couple of years researching what are the protocols that people are either using or very intrigued about right now. And in the end, by 2019, we came up with I believe it was 11 protocols at that time, but we narrowed it down to 10 specific protocols that were being used. Interestingly, most of that set of protocols is covered by understanding the 802.15.4 standard, because that covers Zigbee and Thread and 6LoWPAN and ISA 111A and wirelessHART. All of those fall back to that 802.15.4 spec, which if I can tell anyone, if you know 802.11 and you want to know one other standard that is going to help you in your wireless career, learn 802.15.4, because a lot of IoT protocols are driven by that. And interestingly, you'll find out that if you get an 802.15.4 protocol capture system, that there are protocols out there that say they're a proprietary protocol, but they're just running on top of an 802.15.4 chip. And they're actually using it even though they don't let you know that's what the protocol is that they're utilizing. So it's very heavily utilized out there. And then others, for longer range things like LoRaWAN, Sigfox, we'll see how that turns out with their new acquisition in recent years. But we saw that there was this great need for an understanding of those other protocols. And at first, you'd think, well, it's just an evolutionary leap to go from 802.11 to these other protocols. And in some ways it is, but in other ways, because the very model is different underlying the design intentions of these protocols, it becomes much more than an evolutionary leap, because you have to understand the different world of the applications you're using. In Wi-Fi, we're used to business level applications. We're used to high data rates. We're used to needing to push a lot of information through. And in IoT, we're more focused on needing reliable delivery of a little bit of information. And we're not so focused on having to get a lot through. And
low power. Just today, I was listening to Qualcomm give a presentation on a new chip that they're pushing out, QC730, which is Wi-Fi 4, 802.11g, old technology, but super, super low draw, as in less than BLE power draw, but it's old Wi-Fi. And some audience members were like, how come you didn't go to Wi-Fi 6? He goes, because we wanted low power. We wanted a Wi-Fi IoT chip and has different needs. So as you mentioned, there are different needs for different applications. We're just in the Wi-Fi world used to bigger, faster, more. But a lot of times I have some customers who are still running 802.11g in hotels, and they're like, why change? I can run full Netflix 4K video, easily runs over 802.11g.
Yeah, it's true.
When you talk about IoT, it's not even near that. And so thus these other protocols. So when you went out looking for examples of IoT protocols, you came across that list of 11. How did you go about figuring out which ones to teach, or you teach them all?
Well, we don't teach all of them equally. All of them get a mention, and more, actually, even more than the 11 will get a mention. But as far as testing on protocols, we determined that like we do everything with CWMP and the Wi-Fi track. We got together a group of subject matter experts and let them argue for a few days and decide what needs to be covered in these certifications. And we call that a job task analysis. So we get a JTA group together and they determine what's going to be covered. And that's where the weighting comes from as to how much we put into this protocol versus that protocol and so forth. And for example, particularly once you get in the IoT track up to the CWICP certification, which is for a lot of people kind of like CWAP is second after CWNA. CWICP is often second after CWISA to people because it's the one that goes deep into how the protocols work. And
you might want to just take a step back for our audience. You live in the world of CWNP acronyms and titles.
That's true.
So let's back up. In the Wi-Fi side, you have a whole series of from like below CWNA for starters or sales guys to CWNA, and then there's a security, a design, and a protocol analysis track. In the IoT side, you want to step through what those are. Yeah,
so like the Wi-Fi track, which was CWNA ultimately through CWNE, in the IoT track, we have the same thing, only we end with CWISE instead of CWNE. And along that journey, you have 4 certifications, just like in the Wi-Fi track. Originally, we thought there might be 5 in that track because it is a big world in comparison to Wi-Fi, but it ended up working out to be the same number. So you have the CWISA, which is kind of like the CWNA at your beginning point, and you learn the fundamentals of IoT, the basics of RF, those kinds of things. So a lot of the same kinds of stuff you learn in CWNA, you learn there because not everybody does the Wi-Fi first. So we want to make sure they have that foundation. But then the focus shifts from the RF and the antennas and the hardware over to information about IoT wireless protocols in CWISA. Then the next level, the professional level, there are 3 certifications. There's the CWICP, which is the IoT connectivity professional. Then there's the CWIDP, which is the IoT design professional, and the CWIIP, which is the IoT integration professional. And
which is more like the protocol itself.
What's that?
The IP is like the AP on the CWAP track.
The CWICP is the closest to the AP. The IIP goes to a higher level. So we're taking that data that is being generated from your wireless IoT end devices, and we're asking, what do we do with it now? How is that integrated into the enterprise systems so that it brings us value? This was something early on in a lot of early IoT projects, whether wired or wireless, that they found. They spent a lot of money. They implemented all these end devices with sensors and actuators, and they put it all out there, and they were all working. But the organization said, well, we're not doing anything with this. So we've got all this great stuff, but we're really not using it other than just maybe firing off an alarm for a plant manager to know they needed to go check on some device. But other than that, there was no long-term trend analysis. There was no utilization of this data to make our business better. And so what the integration professional is about is understanding how do we take disparate systems and the data they generate and integrate them. And I'll give you a good example of that. In the industrial space, you have PLCs and you have SCADA systems that deal with the harvesting of all this data from industrial systems. And that goes way back. We're talking 60s and 70s, right? And many of those systems use a protocol called OPC UA. And OPC UA is this kind of proprietary protocol with a proprietary payload that is used just in those industrial environments. It doesn't talk to the IoT world that we're building now. And so what people will do is they get these converters, these gateways that sit between OPC UA and something like MQTT, which is a common IoT protocol. So they convert OPC UA into MQTT. CWI IP is all about how does all that stuff work? How do we do that so that we're actually able to plan a whole system that will function well in an environment? And so that's really what that one is about. And so back to our original question of, what protocols do we teach and how do we go into them? CWICP is all about that. That's where we look at, in the end, there are 10 protocols that are covered in detail, but some of them in more detail and less than others. Like Z-Wave, for example, is probably covered in the least level of detail of all the 10 protocols in that book because it's very common in consumer space, but it's not as common in the enterprise space and industrial spaces, although it's seeing some entry into some areas in building management and things like that. So that's really how it comes down. We look at what's out there, then we get the team of subject matter experts together. We let them discuss it, sometimes heatedly, and decide what and how these things should be covered.
So let's take someone who has a CWNA already, or they might have been working in Wi-Fi for a while. What kind of path would you recommend for them to go through this if they wanted to pick up a new set of wireless skills?
Most likely the best thing to do would be to go with that CWISA and then the CWICP. And the reason is that's going to give you the knowledge of layer 1 and layer 2 in the IoT world. And that's going to be equivalent to then much of what you learned on the Wi-Fi side. You're going to get that same kind of knowledge about these IoT protocols. And just to throw a few out there, I've already mentioned some, but some that were not mentioned before, BLE is one of them. So we cover that because with the enhancements in Bluetooth 5 and BLE that came along, it is actually a very useful IoT protocol now, rather than the early days, or it was really just good for headphones and stuff like that. It wasn't all that great for a data transfer protocol, mainly due to range limitations. They've proven links of over 1 kilometer now with BLE5, and this is because of some of the new PHYs that they implemented in the later versions, and we have the chips now that can do all of that. And so it's another protocol that can be utilized, and we're seeing it more in lighting and things like that, starting to come into that than anything, but we'll see more of it. Mostly, again, I think we're going to see that on the enterprise side. You're not going to see that as much in industrial. And the industrial world is its own world, and they want protocols that are built for them. That's why they love ISA 111A and wirelessHART, because they were built for them. And that's also why you don't see ISA 111A and wirelessHART in the enterprise space, because they don't worry about those. Those are industrial protocols. And so we see them kind of separating in that way, continuing. But we're also seeing a lot more integration between OT, operations technology, and IT, which I think is a good thing because it gives better holistic use of all that data to make companies better, more efficient, and to bring more value to their stakeholders.
Well, you mentioned starting out with this kind of couple inches deep, mile wide, cover all of them. I know there's something that you and I both agree on, because I've seen your videos before, that it's very valuable when someone's learning to have a home lab.
Yeah.
In Wi-Fi, in my experience and in asking people who have achieved CBNE, it's like 100%. People use a home lab to get ahead. If someone's trying to branch out into these other wireless technologies, how would you go about building a home lab with IoT devices?
Yeah.
I mean, other than, I have my Nest or the consumer grade ones. What's the process? Is there some equipment that someone could get that kind of piggybacks on top of the tracks that you mentioned?
For a home lab, to keep costs down, what I generally recommend to people is Raspberry Pi and Arduino-based things that you can build that behave and function exactly like any kind of industrial device that you would get as far as how they actually work. They just may not have that same level of durability that you would find in those devices. So if you get that, the nice thing about the Arduino and the Raspberry Pi is you can get adapters, hats, modules, they call them different things depending on what you're getting, that work with all of these protocols we're talking about. So there are some for 802.15.4, there are some for LoRaWAN, there are some for Sigfox, and so forth. So you can get these adapters, and then you can actually go through the process and build your own gateways, you can build your own end devices, and you can build the whole thing, test it, understand how it works. You can even utilize those to build your own protocol capture devices, because there's open source software that allows you to capture and decode 15.4 frames, for example, and then wirelessHART has the decoders, so you can just open that 802.15.4 frame in wirelessHART and look at the bits and bytes and understand how the protocol is working. So there's definitely some flexibility there.
You're speaking to my heart there.
Hello, podcast listener. Did you know you can get even more nerdy podcast goodness? Check out Heavy Networking, a weekly conversation about routing, switching, WANs, LANs, data center networks, and more. Each episode features network engineers and industry experts going deep on existing technologies, as well as looking over the horizon to see what's coming next and how to get ready for it. We also offer insights and tips on professional development and career advancement. From access control to zero touch, from the CCNA to the CCIE, Heavy Networking is the podcast for network engineers. Listen wherever you get your podcasts.
I think, having taught lots of people Wi-Fi, the ability to stop, have a capture utility that you can capture what you're doing, set up a situation, capture it, go back and look at the captures is a perfect way to learn.
Yeah.
So if people use that same technique when they were learning their CWAP to get the nitty-gritty of Wi-Fi, they can do the same thing with 15.4.
Yeah. And that's why I tell people, I mean, you can get the modules for LoRaWAN, and that's fine, but LoRaWAN uses a proprietary PHY and MAC, and getting decoders for it is a lot harder. So it's challenging. In fact, most of the information we know about how it's called chirp spread spectrum, that's the physical layer in LoRa, and knowing how it works is mostly by reverse engineering, where people have actually done spectrum analysis, looked at what it's doing when they know data X is being transmitted, here's what it looks like, and from that they've kind of figured out how the modulation works and so forth. It's a lot harder to do it with that, and that's why I tell people start with 802.15.4, which is standards based. We have all kinds of ways that we can look into that and learn how those protocols are actually working. And that's a good place to start because of that.
And you might already have spec-an tools that can see 2.4. So you can actually, by the way, one of the questions I get most when I'm talking spec-ans to people is BLE. They see the 2.4 spectrum and there's something going on. What's over happened right between 3 and 4? There's a spike there. Yeah, it's BLE. Well, how do you know? Well, if you understand the BLE protocol and you know what those are doing, then and you can actually see the one on the left of channel 1 as well. The channel 13 one, we normally don't look up there to see that. But I think that's a good recommendation, because if you start closer to the frequencies we're used to, there's a lot of really good IoT frequency work in non-2.4 and 5 gig.
Yeah.
But that might be a nice transition, because you can use some of your same tools you already have.
Absolutely, yeah, and that is the benefit, because all the protocols that we focus on in the track that use 802.15.4, because 15.4 does support some other frequencies as well, but the ones we focus on, the more popular ones that are out there, as I've mentioned, ISA 111A, wirelessHART, Thread, 6LoWPAN, they primarily are implemented in 2.4 gigahertz. ISA 111A and wirelessHART are only in 2.4 gigahertz, but 6LoWPAN technically is not constrained to that frequency band, but most of what's out there today is. And so if you have a spec-an, then you have the ability to look at that, because if you bought it for Wi-Fi, then you have 2.4 gigahertz coverage. Absolutely.
Yeah. So in this track that CWMP program has built, what's the capstone? So in the Wi-Fi side, it's CWNE. How does that work in the IoT space? Yeah,
so in the same way, we have an expert level at the end, but just like with the CWNE, you have to pass the 4 IoT track certifications, and for CWIC, we require CWNA, because we don't feel that there's enough Wi-Fi in that track alone to say that you can call yourself a wireless IoT solutions expert if you don't know a little more about Wi-Fi than what we teach in that track. So it requires ultimately 5 different certifications when you include CWNA. And then you apply for it like you do for your CWNE. It is a little bit different at this time. It's a video interview-based application. So rather than writing essays, you meet with me or another person at Certitrek, and we interview the person with a technical interview that is then sent to the board of 6 members, and that board is our first 6 CWISEs as well as who it is. And they actually are people who help build the whole program along the journey. And so your video is sent to them. They review the video and look at your resume, making sure you meet the 3-year requirement and that you've passed all your certification exams and that you have one non-CWNP certification like CWNE. And if you meet all that and they approve of your video, they feel the interview is good, then you get through. And so we did this different method with CWISE because with CWNE over the years, a lot of questions have come up about, how do I write these essays and how do I do that? And the whole point of the essay is the person has the opportunity to show that they know the technology at a very deep level so they can deal with a troubleshooting scenario. They can deal with a design scenario or something like that. What the video interview allows us to do is on the spot live, they have no idea what the questions are going to be before they meet with the person for the interview. They're given a scenario and asked to give some ideas about how they might troubleshoot it and what they might recommend looking at. They're given a scenario and asked what protocols might be useful to design an IoT solution for this scenario. And right there live, you find out if they know the technology at an expert level or not. And that's an interesting thing. It also, I think, makes it easier for people to show their technical expertise if they have some barriers, because some people do have barriers like writing, putting their thoughts on paper. It's very hard for them. They don't like that. But just because they lack that ability doesn't mean they're not an expert. And they may have the expertise and they would do fine in an interview. To be fair, some people are probably more challenged by the interview than by the written essay.
Put some pressure on some people. Whatever they ask, I can't prepare.
Exactly.
But it's probably good for both sides. If you were going to start over again in your career in wireless, would you start on the IoT side or the Wi-Fi side?
Wow, that's tough because, there's the sentimental connection to the Wi-Fi side that makes it almost painful to say that I would start on the IoT side. But if I can pull the sentimentality out of it and all the emotions, honestly, I would definitely start on the IoT side with plans to do it all. And the reason I say that is just because of the potential growth that's coming in the next decade on that IoT side is huge. Now, of course, I know that because I have to look at all the research and I'm continually looking at the statistics. And so I know what's going on there and where that growth is coming. If I was someone who didn't know that, I'd probably lean toward the Wi-Fi side because the appearance is that that's certainly way more popular and there's more opportunity there. But with what I know about the future that is coming in these industrial areas, oil and gas, with all the automation we're doing, with the self-driving cars that are coming, which in part will be linked to Wi-Fi and other technologies as well, with everything that's coming down the road in the next 10 years, our world is going to change, particularly in first world countries. It's going to change drastically. And if I wanted to be prepared for that, I would definitely want to go the IoT route first. But my plan the whole time would be to do the Wi-Fi side as well, because they're both going to be so important. And I think that's what I would say, but it's really hard for me. Even while I'm saying it,
it just hurts.
Yes, I'm wanting to say, no, do the Wi-Fi.
That's why I wanted to have this episode for the podcast, because a lot of us started in the Wi-Fi side, but we really are wireless. And
absolutely,
a lot of people in the Wi-Fi side started in ham radio, because there's a lot of the same things, because we're talking about waves and SNR, and actually a very small percentage of people came from cellular, because I don't know why. They just they're almost diametrically opposed in a lot of ways. But the final question I wanted to ask you is, what's your opinion on Wi-Fi HaLow? It kind of is a bridge between the two, and I'll let you answer. I have my own opinions, but what do you think about Wi-Fi HaLow? Yeah,
well, it's interesting because early on it looked like, man, this is going to be the end-all solution. You won't need 802.15.4. This is going to give it to us without needing the 2.4 gigahertz band, and it's going to be great for IoT solutions. And there was a lot of interest. There was a lot of research. There were even some test bed implementations. It looked like this was going to grow, and then it kind of fizzled out, disappeared. And you really didn't hear much about it. But now in recent years, in the last
recent months even,
yeah, we're seeing a trend back toward it with a lot of interest again in that. And so, I obviously can't completely foresee the future, but I actually see that it's coming back as a pretty major contender. One of the things that we can look at in trend analysis, not a lot of people look at this, but when you look at research papers, what are mostly college students are writing these research papers, and they're professors. When you look at research papers and you look at what are they writing about, what are they studying and researching in college? Because if you think about it, if I'm in college and I'm studying Wi-Fi HaLow and I do a project on implementing Wi-Fi HaLow for, a water supply monitoring system, let's say, then chances are when I get into my career in industry, I'm going to fall back to what I know. And I'm very likely to end up implementing the thing that I tested out in college or something very similar to it. We've actually seen an increase in research papers over the last 5 years that continues to grow year over year in Wi-Fi HaLow. Whereas we saw that same thing very early on when the standard was first ratified. There was an increase in research, but they were all simulation based back then. It was all simulating how the protocol works and what kind of performance will you get. These recent papers in this trend are different. They are actual implementation cases where they're implementing Wi-Fi HaLow. They're doing something with it in agriculture or environmental studies or something like that. And they're seeing the actual results they're getting out of it. And what that says to me is, first of all, they have the chips available to them to actually do the thing now, right? They don't have to simulate this. They've got the actual hardware to make it happen. And so when I look at that, and then I also see the talk in industry and I see the new hardware that's coming out that supports it, I think there's definitely a potential for a significant upward trend in use in the future.
Is HaLow one of the 10 that are in your strong list?
It's not, because back in 2019,
it wasn't really going to be a thing.
Yeah, so it gets mentioned, right? It's in there as a mention. This is a protocol that's out there, but it wasn't mentioned as anything covered. I mean, back then we thought of it about the same as TVHT.
Yeah. Could be happening. So
yeah.
Well, Tom, I appreciate your time today talking to us a little bit about IoT and some of the other wireless. We might have to come back on a different episode and talk about the other wireless that Wi-Fi people are now getting into, which would be private LTE, private. Yeah. Well, they haven't figured out how to call it. Private 4G, private 5G, private LTE, CBRS, depending on what country you're in. But there's an entire other wireless protocol that we could have the same discussion about.
Absolutely.
Well, thanks for your time.
Sure thing.